The Earth is losing its invisible defense. Over the past 3,000 years, our planet's magnetic field has already lost about 30% of its strength, and it's still weakening. But here's the detail that almost no one knows. This might be just the beginning of something much bigger. Stay with me, because I'm about to show you how this invisible shield protects us every day, and what could happen if it starts to fail. Earth's magnetic field is our first line of defense, an invisible barrier stretching far into space. Without it, our planet would look a lot like Mars, a barren world, stripped of its atmosphere by the solar wind. But what exactly is this shield and how does it work? Earth acts like a gigantic magnet, but instead a solid piece of metal. The source of this magnetism is a vast ocean of liquid iron constantly moving beneath our feet. Located about 1,800 miles, 2,900 kilometers, deep, this molten sea generates colossal electrical currents, traveling thousands of miles per hour as the Earth rotates. This natural process is known as the geodynamo, a kind of planetary power plant. The result is a magnetic bubble around Earth called the magnetosphere. However, instead of being a perfect sphere, this bubble takes on a windsock-like shape in space. The solar wind compresses it on the day side and stretches it into a long tail on the night side. Now comes the truly fascinating part. This magnetic field not only protects us from the solar wind, but also creates two gigantic donut-shaped zones known as the Van Allen belts. These regions capture and trap highly energetic particles from space, functioning as a shield against cosmic radiation. Think of them as Earth's very own particle accelerator, deflecting and holding back radiation before it can reach the surface. But here's the problem. This shield isn't as stable as we once thought. In fact, something strange is happening to it, and much faster than we expected. Remember when I mentioned that our magnetic shield is weakening? Scientists have identified a massive weak spot in the magnetic field over the South Atlantic Ocean, stretching from South America to Africa. This phenomenon is called the South Atlantic Anomaly, and it works like a crack in our magnetic armor, where protection is significantly lower than in the rest of the planet. And this weakness isn't just a scientific curiosity, it's already causing problems. Satellites passing through this region frequently experience failures and electronic interference. It's as if they're moving through a vulnerable zone where our protective shields simply can't block all the space radiation. But that's not all. Earth's magnetic field is also changing in other unexpected ways. Our magnetic poles are not fixed, they're moving. The North Magnetic Pole is shifting towards Siberia at an astonishing speed of about 34 miles, 55 kilometers, per year, 3 times faster than it was in the 1990s. Now, imagine if your compass started pointing in different directions every year. This phenomenon isn't new. By studying ancient rock formations, scientists have discovered that Earth's magnetic field has completely reversed several times, with north becoming south, and vice versa. The last major reversal happened around 780,000 years ago. But how exactly does this magnetic flip occur? It all goes back to that ocean of liquid iron deep inside the Earth. Changes in its flow can weaken some parts of the magnetic field while strengthening others. During a reversal, the field doesn't simply disappear and then reappear flipped. It's a gradual process, more like a dimmer switch fading down before rebuilding in the opposite direction. This process can take anywhere from a few centuries to thousands of years to complete. But this doesn't mean we would be completely unprotected during the transition. Instead of a simple magnetic field with just 2 poles, multiple magnetic poles would appear in different locations around the planet. It's as if, for a time, compasses worldwide would point in different directions. However, scientists believe that we are not necessarily heading toward a full reversal at this moment. What might be happening is a smaller phenomenon known as a geomagnetic excursion, periods when the magnetic field weakens significantly but later recovers without fully reversing. These excursions occur much more frequently than full reversals, and there are signs that we might be entering one now. But what does all of this mean for life on Earth? First, the good news: we are not heading for an apocalyptic scenario. The planet has gone through countless reversals and excursions before, and life has persisted. There is no evidence that these changes have caused mass extinctions in the past. However, the most immediate effects can already be felt in our technology. Satellites passing through the South Atlantic Anomaly need extra shielding, and some even shut down their sensitive systems temporarily when crossing this region. If the magnetic field continues to weaken, these problems could become more frequent and impact not only satellites, but also power grids and communication systems on Earth. And what about radiation reaching the surface? Here's something most people don't know. Our primary protection against cosmic radiation is not the magnetic field, but rather the atmosphere. It acts as a thick shield equivalent to a 13-foot, 4-meter, concrete wall, absorbing most harmful radiation. Even if the magnetic field weakens drastically, the atmosphere will continue to protect us. However, some forms of life might face challenges. Animals that rely on the magnetic field for navigation, such as sea turtles, whales, and certain migratory birds, may need to adapt to a world where their internal map no longer works as before. But since these changes happen over many generations, these creatures would likely have time to develop new navigation strategies. Scientists estimate that at the current rate of weakening, it could take centuries or even millennia before we reach a truly critical point. This gives us time to prepare. Space agencies are already developing better radiation shielding for satellites and spacecraft, while power grid operators are investing in technologies to protect infrastructures against geomagnetic storms, which could become more common as the field weakens. We are living in a unique moment in history where we have the technology to observe these changes in real time. Satellites like those from the European Space Agency's SWARM mission constantly monitor Earth's magnetic field, allowing scientists to study its behavior like never before. The more we learn, the better we can prepare for the future. So, while Earth's magnetic field is indeed changing, there's no reason to panic. This is a natural process that our planet has gone through many times before. The difference now is that we are here to witness, study, and adapt to it. If you found this analysis of Earth's magnetic future interesting, subscribe for more videos about the incredible transformations happening to our planet. And let me know in the comments, what surprised you the most? The fact that the magnetic field is weakening, or that our atmosphere is actually the primary barrier against radiation? Don't forget to check out the video on the right and subscribe to the channel. Thank you for being part of our community.